So that we'll see now the relation between frequency of rotor current and supply frequency. So assume rotor is stationary initially. Now the relative speed between rotor winding and a rotating magnetic field ns, that is initially the relative speed is 0 when rotor is about to start. Then ns is given by f is equal to p ns by 120. Fine, n is equal to 0. When rotor speeds up, when rotor starts increasing its speed and try to catch up the speed of rotating magnetic field speed, then the relative speed will be ns minus n, where ns is equal to rotating magnetic field RMF speed and n is equal to speed of a rotor. Now rotor frequency is given by, once again we got general formula p n by 120, but what is n here? P n by 120, but what is n? See, n is the relative speed, ns minus n. We can substitute the relative speed as ns minus n here. So p into ns minus n by 120. So that will give the rotor frequency here. We have got a formula, slip s is equal to ns minus n by ns. What is ns minus n? Is equal to s into ns, and s into what is ns? 120 f by p. So ns is equal to synchronous speed is equal to 120 f by p, the synchronous speed of rotating magnetic field. So s into 120 f by p. Now is substitute back here ns minus n by 120, ns minus by, if we substitute p into ns minus n by 120 here, so p by 120 as it is, you substitute value for ns minus n. So ns minus n, you can substitute this value s into 120 f by p here. We'll get s into f. So rotor frequency is also called as slip frequency, is given by fr is equal to s into f. We'll end up with s into f. This is one of the important derivation to find out the rotor frequency or slip frequency. We move on to problems. Problem number 1. A 12-pole 50 Hz 3-phase alternator is driven by 440 volt 3-phase 6-pole induction motor running at a slip of 3%. Find frequency of EMF generated by the alternator. Now, we have to see the problem. It is given as a 12-pole 50 Hz 3-phase alternator is driven by 440 volt induction motor. So that means to say the speed of this alternator is same as the speed of the induction motor, that is the speed of rotor of induction motor, because this rotor is coupled to alternator. N, what is the speed of rotor? Speed of rotor of a motor, induction motor, is n. So this n is same as the speed of alternator. Let's see, induction motor. For induction motor, ns is equal to 120 f by p. So 120 f is a 50 hertz, is given 50 hertz, is same as the supply frequency, divided by 6 pole of induction motor, 6 pole induction motor, so 1000 rpm. So that is a rotating magnetic field of induction motor. Speed is given by 1000 rpm. To find out the rotor speed, ns into 1 minus s, so 3% slip has been given into 1000, 970 rpm we got. Once you find out the speed of this rotor, I already told the alternator is driven by induction motor, so alternator runs at the same speed as 970 rpm because it is coupled to the induction motor. So once you find out as speed of the alternator, that is as 970 rpm, then we can find out the frequency of EMF generated by the alternator as Pn by 120, but here ns is 970 because this ns is related to this synchronous speed, is related to the alternator. So we need to substitute here the speed of alternator here. So 970 by 120, you will get 97 Hz. The second problem, a 6-pole alternator running at 600 rpm supplies a 3-phase 4-pole induction motor. If the induction motor induces EMF makes 2 alternations per second, find the speed of the motor. Here the alternator is it supplies a three-phase induction motor. That means say three-phase induction motor is given supply from the alternator. So which is having 6 pole, 600 rpm, which is running. The alternator specification is 600 rpm and 6 pole, and induction motor specification is given by 4 pole. Fine. Start with alternator. 6 pole, 600 rpm, synchronous speed of alternator 600 rpm, it has been given. And to find out the supply frequency, Pn by 120, Pn 600 by 120 will get 30 Hz. I already told that the frequency of the rotating magnetic field is same as the supply frequency. So for induction motor, it makes 2 alternations per second. That means to say 2 alternation means one is positive half cycle, one is negative half cycle. 2 alternations. So that means say 1 cycle per second. It is making 1 cycle per second. That means say 1 Hertz. The frequency of a rotor is 1 Hertz. It has been given. So induction motor induces EMF makes 2 alternations per second. So that means say its frequency is 1 Hertz. We have got formula Fr is equal to S into F. We have seen the derivation where S is equal to slip, where F is equal to supply frequency or frequency of rotating magnetic field, where S is equal to Fr by F. So that is 3%. Slip we found out. So what you want to find out actually? Find the speed of the motor, that is N we need to find out. So N we need to find out. On the way to find out N, we found out slip. So once you find out slip, then we need to find out this Ns. This Ns is equal to synchronous speed of rotating magnetic field of the induction motor is different from this Ns. This is the synchronous speed of alternator. This what we want to find out is synchronous speed of rotating magnetic field, which is important for motor now. Now what is Ns? 120 F by Pm. So now P it will change now. So P is a pole of a motor is 4. 120 in the F, same as supply frequency. This frequency will not change, 900 rpm. So once you find out the Ns, we can find out the value of N, because S we already found out, Ns we found out, we can find out N as that the speed of rotor as 870 rpm. Next, problem number 3. A 4-pole 30 HP 3-phase 400 volt 50 Hz induction motor operates at an efficiency of 85% with a power factor of 0.75 lag. Calculate the current drawn by the induction motor from the mains. As given data, P is equal to 4, V line voltage of 400 volts, efficiency has been given, power factor has been given. So we need to find out the current drawn by the induction motor. So to find out the current drawn by the induction motor, we have got formula input power P is equal to root 3 VL IL cos phi. From this we can find out the line current IL. So to get the input power P, we have got output 30 HP output of a motor is converted into kilowatt, that will get as 22.06 kilowatt. So output by efficiency, input is equal to output by efficiency. So efficiency is 85% is given, and we will get input as 25.96 kilowatt. So once you get the input as 25.96 kilowatt, convert into watts, divided by root 3 into VL is given 400 volts, power factor has been given, we can find out the line current straight away as 49.94 amperes. Problem number next 4. A 5 HP 400 volt 50 Hz 6 pole 3-phase induction motor operating on full load draws a line current of 7 amperes at 0.866 power factor with a 2% slip. Find the rotor speed. So it is having only one induction motor details now. So everything of induction motor has been given. This is 6 pole, 2% slip, power factor has been given, frequency of supply has been given, as well as rotating magnetic field frequency has been given. Output 5 HP converted into watts, we will get 3.677 kilowatt. Line current 7 ampere. So it has been given a line current we need to find out the rotor speed. To find out the rotor speed, we have got formula ns into 1 minus s, where s is the slip is given 2%. We need to find out ns. So ns is equal to synchronous speed of rotating magnetic field. So 120 f by p, 120 into frequency 50 Hz is given by pole of induction motor 6000 rpm. Once you find out ns, we can find out n, speed of a rotor, as 980 rpm. Next problem. Problem number 5. A 3-phase 6-pole 50 Hz induction motor has a slip of 1% at no load and 3% at full load. Find the synchronous speed, no load speed, full load speed, frequency of rotor current at standstill, and frequency of rotor current at full load. So is given the data, number of poles 6 pole, and no load slip and full load slip has been given separately, 1% as well as 3%. First you have to find out the synchronous speed of rotating magnetic field. Ns is equal to 120 f by p, 120 into f, frequency has been given as 50 Hz. P 6 pole, actually it has to be 6. So 120 f by p, it has to be 6. You will get 1000 rpm. So 1000 rpm that you will get. And no load speed, it is given as s into ns minus n by ns, or n into ns into 1 minus s. So s is equal to ns minus n by ns, or with this we can find out n is equal to ns into 1 minus s. So this is the rotor speed. So we need to find out no load speed. So no load speed, if you substitute here no load slip, you will get no load speed. So n0 is equal to 1 into s0 into ns. Ns is equal to 1000, is found out, 1 minus no load slip given as 1%. From this we can calculate no load speed as 990 rpm. For a full load speed, slight change, you have to substitute here full load slip to find out full load speed. So full load slip has been given as 3% here. The formula remains same, n is equal to ns into 1 minus s, but you have to substitute here full load slip. You will get as 970 rpm. Next, frequency of rotor current at standstill. The frequency of rotor current, so that is what is frequency of rotor current at standstill? At standstill, what is s? S at standstill means rotor is not moving. When n is equal to 0, slip is equal to 1. When the slip is equal to 1, Fr is equal to f. That means to say, at standstill, frequency of rotor current is same as the frequency of supply, that is 50 Hz. Frequency of rotor current at full load. At full load, we need to have here SF, full load slip. Formula same, we have to find out the rotor current frequency. Fr is equal to S into F, where S is equal to 3% now here, into F. We will get 1.5 Hz. Next problem. Problem number 6. A 6-pole induction motor is supplied by a 10-pole alternator which is driven at 600 rpm. If the induction motor is running at 970 rpm, determine its percentage slip. A 6-pole induction motor is supplied by a 10-pole alternator. So that means the input to the induction motor is 10-pole alternator which is driven at 600 rpm. The alternator speed is 600 rpm, 10-pole. Induction motor specification as given as it is running at 970 rpm. We need to find out slip. Now find out percentage slip is equal to ns minus n by ns. What is this ns? Ns is equal to, this is the rotating magnetic field speed, synchronous speed of a rotating magnetic field. N is given 970 rpm, speed of a rotor has been given. Motor is running at 970 means it is speed of a rotor. We need to find out ns. How to find out ns? To find out ns, we have 120 f by p. What is this p? P is equal to poles of a motor, not the alternator. This is a motor pole, because we are finding is synchronous speed of RMF. For that we need to find out F, because F is not given. This F is same as the frequency of supply. How to find the frequency supply? By using the alternator details. So P N by 120, P 10 pole, 600 RPM, it is running at 600 RPM, 10 pole alternator, divided by 120. From this we will get 50 Hz. Once you get 50 Hz, we will substitute back here to find out this NS, 1000 RPM. Once you find out this NS, we can find out percentage slip as 3%. Next problem. A 3-phase induction motor has 6 poles and runs at 960 RPM. So it is straight away given a 3-phase induction motor specification. On full load, it is supplied from alternator having 4 poles and running at 1500 RPM. Calculate the full load slip of the motor. It is supplied from the alternator. That means so alternator supply is given to the induction motor, in which this alternator having 4 poles and running at 1500 RPM. So this is the alternator details. Once you get the alternator details, we can find out the frequency of alternator or frequency of supply as 50 Hz. So Pn by 120. This Pn is equal to 1500 of alternator. We got frequency. Once you get the frequency here, this frequency is same as now RMF frequency. Now come back to induction motor, which has got 6 poles, 50 Hz, same as this, and it is rotating at 960 RPM. 960 RPM, it is given as it is rotating at 960 RPM, that is N. So Ns is equal to 120 F by P. Now P is the P of motor, because Ns is RMF speed. 120 into 50, same as supply frequency, by PM, 6 pole motor. You get 1000 RPM. Once you get Ns, we already know that this is N. We can find out the slip as 4%. That is calculated the full load slip. So that is 4%.